All right, guys, welcome. Today we're looking at day 20. We have two lessons we're going to go through today, 65 and 66. So lesson 65, we're looking at circumference and pi. So circumference, again, when it's a circle, we don't say perimeter of a circle, we call it circumference. And so that's the distance all the way around our circle. And we use pi, pi, which is a number through generations and generations of calculations trying to figure out what is this constant in relation to area of a circle and circumference of a circle. There was a constant that they kept coming up with. Originally, they used 3 just kind of as a rounded number, and then they got more and more accurate. So we'll use 3.14, which is a rounded version of it, or sometimes we'll use 22 sevenths, 22 over 7. For our calculation. We've talked about circles before, pi r squared for area, 2 pi r for circumference. So we need to review that. Again, we have a circle. We use pi, radius, diameter when we're working with circles. Radius is from the center to the side. So 2 radii, 2 of those would be the diameter. So if we know the diameter, the radius is half. If we know the radius, it's double for the diameter. And then the circumference is all the way around. So those are highlighted words. Hopefully we remember those. If not, now we do. So radius, diameter, and circumference. A circumference of a circle, this symbol right here is what we use for pi. Okay, so it's pi, or we'll use 3.14, 22 sevenths. Those are rounded numbers. Again, pi is actually in irrational numbers, so the decimal continues on forever. As we see right here, it continues on, but it goes on infinitely. It's never repeating, and it never terminates. So mathematicians for hundreds of years have calculated out to 10, 100. I know people even now, they have contests where who can memorize pi out to 100 decimal places. That seems like a lot of mental energy just to say you did it. But if you want to do that, by all means, go for it. But we're not going to require anything like that in class. So, and there's computer programs that have taken it, I think, to like 1 billion decimal places. A lot of effort just to, we know it goes on forever. So we could take it out to however many decimal places. But for our sake, we'll usually use 3.14 or 22 sevenths. And it'll tell you in the problems, either in the book, the examples, or on tests, reviews, which one to use. Sometimes we keep it in terms of pi. Sometimes we use 3.14. Sometimes we use 22 sevenths. Usually they're really nice, and whichever one they give you, it makes sense why. Like 22 over 7, maybe we are able to cancel out that 7 and we end up with a whole number, which is nice. Or if we use a decimal, we take it out to 2 decimal places instead of 20 or 50. If you do it on your calculator, there's a button for pi. I think it takes it out to 9 or 10 decimal places. So again, we'll use whatever we're told in the examples. So circumference is pi, that number we just talked about, times the diameter. Or since diameter is 2 times the radius, we can use 2 times radius times pi, or 2 pi r is usually how it's written. So the radius of a circle is 10 centimeters. Well, pi times 10 times 2, okay, or pi times 20 equals 62.8. This little symbol right here looks like a bent equal sign. That means it's about. Since 3.14 is a rounded version of pi, we say it's about 3.14. And then our circumference is about 62.8 centimeters. Again, it's circumference, just like perimeter, so it's one-dimensional, so it's just our units, centimeters, inches, feet, whatever. It's not squared or cubed. Example 2, find the circumference of each. Okay, use 3.14, use 22 sevenths, and leave pi as pi. So pi times the diameter, 3.14 times 30. Use our calculator. For that, we get 94.2. 14 times 22 sevenths. Well, I know the 7 and the 14. I can factor out a 7 out of 7 and 14. So I'm left with 22 over 1 times 2. That gives me 44. And then if we're told to just leave it in terms of pi, 10 is the radius, so the diameter would be 20. So 20 pi would be, don't just call it 20, it's 20 pi. Because 20 times pi and 20 are obviously two different numbers. So if we're told to leave it in terms of pi, don't forget to use the pi symbol. Okay. We got 94.2 about. We got 44 feet. And then this one, we can use an equal sign because it is 20 times pi. Now, if we calculated that out to a decimal or a mixed number, we would use the about symbol. Okay. Let's practice that. We'll go over it together. We'll probably do A, B, and C in class. Again, the circumference is pi times the diameter. Pretty simple formula to remember, but even if we don't, it's on our reference sheet. I know we've worked with circles plenty in the past, so hopefully that's mostly review. Okay, and then 66, we're working with ratio problems involving totals. So again, if we're looking at boys to girls, but then we have obviously a total we can come up with, and we know the total of, in the auditorium or in the entire school or whatever it is. Just like always, we have our ratio and then our actual count, the two things that we're comparing, but now we're going to add in a third row that's going to have the total in it. The ratio of boys to girls in the assemblies was 5-4. There's 180 students in the assembly. How many girls were there? Well, we don't know. We weren't given 9, but how did we get that total? Oh, well, if it's boys to girls for our ratio, 5 plus 4 is 9. So that's how we, even though we're not provided, we can easily calculate our total. And we were given the total number of students. We want to know the number of girls. So we're going to set up our ratios. 4/9 equals G, or whatever you want to call it for your unknown, over 180. We're going to cross multiply and divide. So we'd end up with 80. And we could do the same thing for boys, or since we know there's 180 in total, there's 80 girls, well, there has to be 100 boys. So I would probably just find the difference between those to calculate this value right there. All right, so the ratio of football players to soccer players was 5-7. If the football players and soccer players in the room totaled 48, how many were football players? So I'm going to go football, soccer total. What was it? 5-7. Let's make sure we got the right. Football to soccer was 5-7. And we can add those to get our total 5 plus 7. So this is our ratio. Actual count, we were told there was 48 total athletes in the room or whatever. What was it? If the football and soccer players in the room totaled 48, how many were football players? So we want to find our football players. So we'll use F or X or whatever you want to. So 5 to 12, that's our total. Football players to total equals football players to total for our actual count. And cross multiply, I get 12. F equals 240. 5 times 48, where'd my pen go? 40 divided by 12. So cross multiply and divide just like we've been doing, and we get F equals 20. That's the number of football players. And then we can find soccer players. 48 minus 20 is 28. So there's 28 soccer players. If we needed to find that, we weren't asked to. But once we have 2 of the 3, then it's pretty easy to find that missing one. We could still set it up in ratios and cross multiply and divide, since that's a little bit more work. Probably be easier just to find the difference. Okay. So we set it up, we set them up, make sure our ratios are in the correct orientation, then we cross multiply and divide. All right. We'll look at A, B, and C when we return to class. And continue on down the road. So that's all we have for today.